right now at how to convert between vertex and standard form. And we're going to begin with the process of how to convert from the vertex form of a quadratic to the standard form of a quadratic. This is probably the simpler of the two directions, and we're going to begin here with the quadratic y equals parentheses x minus 2 squared plus 4. And let's just refresh our memories a little bit. When we're talking about vertex form, we're talking about y equals a times x minus h squared plus k. And we know that the value hk tells us the vertex of the function. Well, sometimes it's more handy to know what the standard form is. So how do we go about doing that? Well, the first thing that we need to remember is the meaning of this 2. And this 2 means that the factor x minus 2 occurs twice in the function. So now we have, if we rewrite that, y equals x minus 2 times x minus 2 plus 4. So what are we going to do with this x minus 2 times x minus 2? Well, obviously the most simplest thing to do would be to just FOIL this. And we learned FOIL a long time ago. First outer, inner, last. So if we multiply here, x times x, that gives us x squared, x times negative 2 minus 2x, minus 2 times x, minus 2x, minus 2 times minus 4, plus 4. And remember, we've still got this minus 4 that was originally on the end of the function. So don't forget to add it to the end. So we have another plus 4. So in order to write this in standard form, we need to combine these like terms. So y is equal to, I've only got one x squared, so let's write it down. Combine this minus 2x with this minus 2x. We have minus 4x. And combine plus 4 and plus 4 gives us a plus 8. So we now have the standard form of the quadratic, and it's y equals x squared minus 4x plus 8. Y equals ax squared plus bx plus c. Let's try another one of these just to make sure that we have a good handle on how to go about converting from the vertex form of a quadratic to the standard form of a quadratic. So let's clear this off here and try another one. Y is equal to negative 3 times x plus 1 squared minus 5. And the only difference this time is we've got this a value in the front, and we need to make sure that we take care of that as we go along. But again, we have our binomial squared, so let's rewrite this with the binomial written twice. So x plus 1 times x plus 1. And our minus 5 on the end. So to multiply x plus 1 times x plus 1, we're going to FOIL, but don't forget you've still got this leading coefficient of negative 3. So let's FOIL this. X times x is x squared. Outer, x times 1, so plus 1x. Inner, plus 1 times x, so plus 1x. And last, 1 times 1 plus 1. And don't forget your little 5 out here. So now I've got all of this that I FOILed in parentheses, but I've still got this negative 3 in the front. So we need to distribute our leading coefficient here, our a. So negative 3 times x squared is negative 3x squared. Negative 3 times 1x is minus 3x. Negative 3 times 1x is minus 3x. Negative 3 times 1 is minus 3, and then minus 5. So the only step that remains here is to combine our like terms. And when we combine our like terms, we have minus 3x squared, and minus 3x and minus 3x are like terms. So we add them together, we get minus 6x. And minus 3 and minus 5 are like terms. We add them together, and we get minus 8. So there's our quadratic. Y equals negative 3 times the quantity x plus 1 squared minus 5 is the same quadratic as y equals negative 3x squared minus 6x minus 8. Well, what if we want to go the other direction? What if we want to start out with the standard form of a quadratic and change that standard form to vertex form? So let's look at this process of converting a standard form quadratic to a vertex form quadratic. So the one we're going to start with is f of x. Remember, f of x and y, they're the same thing, is equal to x squared plus 4x minus 3. Y equals ax squared plus bx plus c. And let's write down our values for a, b, and c, just so we have them to look back at. A is equal to 1. Remember, if there's no number written here in front of the x squared, that's a 1. B is equal to 4, the number in front of your x. And c is equal to negative 3. So if I want the vertex form, what do you think I probably want in this problem? I probably want to find the vertex. So we've already learned when we were graphing these in standard form that to find the vertex, I have to start off by finding the x value. And the x is equal to negative b divided by 2a. So if we substitute our numbers here, negative b, negative, and our b value is 4, divided by 2 times our a value, which is 1. So 2 times 1. So a little bit of arithmetic, and x is equal to negative 2. So what do I do with that negative 2? Well, I take that negative 2, I substitute it back into my function to find the y value. Y is equal to, and I'm going to substitute this negative 2 for my x value. So negative 2 squared, and remember, I'm substituting negative 2 for x, so that needs to go in parentheses because we're going to square that negative 2, plus 4 times my x, my negative 2, minus 3. Proper order of operations. Negative 2 squared is 4. 4 times negative 2 is negative 8, minus 3. Add them all together, and I get negative 7. So my vertex here is negative 2, negative 7. And remember that when we're setting this up for vertex form, that's h and that is k. So I need y equals a times x minus h squared plus k. Vertex form. Well, this a in this function is the same as the a in our standard form, so we already know what that is. That's 1, parentheses, x minus, well, what did I find for my h value? My h value is this negative 2 right here. So minus a negative 2, quantity squared, plus my k value, the y value of the vertex, which we just found to be negative 7. And generally don't like these double signs here, this minus a minus and this plus a minus. So let's rewrite this as y equals, now do I have to write the 1 for a? No, I don't have to write the 1, so I'm going to leave the 1 out. And I'm going to say x plus 2 squared minus 7. So I now have this standard form of a quadratic converted to the vertex form of a quadratic. Let's do one more of these just for a little bit of practice here on this, and then we'll be done with this section. We're going to change another one of these from standard form to vertex form. Let's start this time with f of x is equal to negative 2x squared plus 8x plus 5. So what are my a, b, and c values here? Well, my a is equal to whatever the coefficient of x squared is, so it's minus 2. My b is equal to the coefficient of x, so it's 8. And my c is equal to 5. So find the vertex. I'm changing it to vertex form after all. So my vertex is equal to x equals negative b over 2a So negative, p-value was 8, divided by 2, times my a value, that was negative 2. And negative 2 times 2 is negative 4, and negative 8 divided by negative 4, negative over negative is positive, is 2. So I have found my x value. So now let's substitute that back in and find y. Y is equal to negative 2 times 2 squared plus 8 times 2 plus 5. I've substituted the 2 for both of my x's. So y is equal to, proper order of operations here, I need to do this squared first. So this negative 2 is still sitting out here in front. And 2 squared is 4. Plus 8 times 2 is 16. Plus 5. A little bit of arithmetic. Negative 2 times 4 is negative 8. Plus 16 plus 5. Add all that together. And y is equal to 13. So my vertex, my HK, is the same thing as xy, and in this case that means that it is 2 13. So now let's write it as vertex form. Y equals a times x minus h squared plus k. So we plug these in. Y equals negative 2 parentheses x minus 2 squared plus 13, and we have converted our standard form of a quadratic to vertex form. So in this lesson we've looked at how to go both directions there to change from vertex form to standard form and to change from standard form to vertex form.